For the ready portion of lesson 2.4, we are looking at arithmetic and geometric sequences. So for number 1, we are starting at 48 and ending at 3, and we're making 1, 2, 3, 4 jumps. I know it's going to be a decimal, but we'll end up with 11.25 as that number that it takes for us to jump each step of the way. So adding 11.25 we would get this. Now, the next one is our geometric mean. So we're going to start at 48, and we need to figure out 1, 2, 3, 4 again. So 48 divided by 3 is 16. I need to figure out what number multiplied by itself 4 times gets me 16. We know that 2 times 2 times 2 times 2 is 16. So 3, 6, 12, 24, 48 would be the sequence. For number 3, similar process, just different numbers. So we'll start with our last term, negative 0.75, subtract our first term, which is minus negative 12, so that'll be a plus 12, and divide it by how many jumps? 1, 2, 3, 4. So we would get 11.25 divided by 4, which would be 2.8125. You're thinking, man, this guy's good. He can divide it all out in his head. It's not the case. Okay. Go into a calculator, drop it in there. So when I add this each time, you would get negative 9.1875. 6.375, $3.5625, and negative 0.75. So I just forgot the negatives there. Get that taken care of. The next one is our geometric. So we'll take the last term, negative 0.75, and divide it by negative 12. Again, feel free to use your calculator to take that 0.75 divided by 12 and see that I'm going to need to multiply by 0.0625 each next step. So we'll take that and multiply it by negative. So we need to figure out how many times a number can multiply by itself. So 4 times x to the 4th power is equal to 0.0625. Okay, think about a number that can multiply. So it's going to be a decimal. Okay, it's going to be small. And because it's going to be small, the first thing that I would recommend doing is figuring out, just take 0.5 and see what happens. And if you take 0.5 and multiply itself out 4 times, you would end up getting 0.625. So what we know is we're going to be taking negative 12 and cutting it in half. Negative 6, cut it in half. Negative 3, cut it in half. Negative 1.5, cut that in half. Sure enough, it is negative 0.75. For the set portion, we're talking about the content that we just found a way to firm up. So we want to represent the natural numbers. The natural numbers, remember, those are our counting numbers, ones that we can make a team with. R is going to stand for our real numbers. Q is our rational numbers. Z is our integers. And N is our natural numbers. So the correct format for this would be D. And this would be read as the set of all x's such that x is a natural number. For number 7, we need continuous linear. Continuous linear. So if it's linear, I know that I'm adding or subtracting. And if it's continuous, I need an explicit equation. If it's recursive, then I'm just taking each next step. It wouldn't be a continuous model. So I need an explicit equation, which means that A and D are out, and I need it to be adding or subtracting each next step. Well, I know that B is going to be multiplying each next step, and I know that C is subtracting 5, so multiplying by 3, but then subtracting 5 each next step. So number 7 would be C. For number 9, arithmetic or geometric sequences will always have something to think about here. Arithmetic or geometric sequences. So remember, arithmetic is linear, geometric is exponential. And the big thing to focus on here is always. What will they always have? We know that they're not always going to be continuous. They're not always going to be discrete. Sometimes they'll be one or the other. We know that they may not always have the domain of the natural numbers or the real numbers. We know that there may not be negative x values all the time. We do know that there is something that's going to be constant. There will be a constant linear change or a constant ratio. We also know that there is some sort of recursive rule that I can always create to find the next step in a sequence. For numbers 10 and 11, it's really taking the vocabulary words from above, okay, the stuff up here, A through G, and making sense of it. So what type of sequence fits with linear mathematical models? Well, something that is going to be adding or subtracting each next step would definitely be a piece to talk about. Something with possibly discrete or continuous relationships. Using that in your favor. Same thing with number 11 with the exponential mathematical model. I'd like to see that you have some sense of what that means to be discrete or continuous in terms of using exponents. Typically, but not always, an exponential model really depends on the situation. Sometimes it'll be discrete, sometimes it'll be continuous. It really depends on, is it always growing, or is it growing at the end of each month or at the end of every hour? For number 13, well, for the go portion, we want to try to write explicit equations. And as it says in the instructions, we really need to know. We need to persevere. Look back at the help guide that you have. If you need it, you can contact me or your teacher. But each next step for number 13, you can see that we are multiplying by 5. So we know that this is an exponential model. So f of x is going to equal our first term times our constant ratio raised to the power of x minus 1. Okay, first term, constant ratio to the power of x minus 1. For number 15, we are multiplying by 1/3. We're dividing by 3, but we'll keep this as multiplication here. Okay. So then for this one, we have f of x equals. Note that we don't have our first term yet, so we would continue working through it. And that's going to be a little bit sloppy here. Hold on. So let's finish our table so that we have our first term. So keep dividing by 3. 3 divided by 3 is 1. 1 divided by 3 is 1/3. So my equation would be f of x equals my first term times 1/3 raised to the power of x minus 1. For number 17, look at the graph and see what you can do. So looking at the graph, I see that my 0 term is 1, my first term is 4, and then it gets pretty far out of hand pretty quickly. Now, I don't have a whole lot to go off of, but what I do know is my 0 term, so my x and my f of x, my 0 term is 1, my first term is 4. I know that this is exponential, so I should be able to say that my constant ratio is 4. My equation would be f of x equals my first term times the common ratio raised to the power of x minus 1. For number 19, same process. Find some spots that you know. This one's going to be a little bit more helpful, maybe. So we have our table, x and f of x. We've got our first term is 1. Well, that helps. Second term is 2. Third term is 4. Fourth term is 8. You should see that each step of the way we're multiplying by 2. So f of x equals first term times common ratio to the power of x minus 1. Number 21, same thing. Recognize where we are. So we have our x and our f of x. So at 0, it's 1, 1, 0. At 2, it is negative 2. Uh-oh. What is happening? So what might be helpful here is looking at a Desmos graph of potentially where this is going and being able to base it off of that. Now, it is a challenge question. It is something for you to think about. Definitely don't want to put it into the video if that is being provided as extra credit, but here's something that might lead you in the direction of where you should be going. Hopefully this helps. Reach out if you have any questions.